We will now look at the third way to avoid data races in C and C++. And that is with memory order consume. But let's summarize the terminology that we have seen and used so far. When we say that A synchronizes with B, that means operation A is done by one thread before, and it's guaranteed to have happened before, and the data written by A becomes visible certainly by the other thread with operation B. And A and B, they can be mutex unlock and lock on the same mutex, obviously, or accesses to an atomic variable, again the same atomic variable, and these accesses are either a store with the memory order release, or a relaxed memory order for the store, and fence with memory order release, or a read with acquire, or relaxed read but a fence with acquire. Okay, so now to the third, and that's called dependency ordered. First, dependencies, they are always within the same thread and therefore called intra-thread. But the third way to avoid data races is called dependency ordered, that some operation is dependency ordered before another operation. Okay, and dependencies, there are two kinds of dependencies, and you are guaranteed to be familiar with both. The first is data dependence. That means that but again, this is within one thread, so it's one variable, one data item that is written, and a later instruction reads this data item. And the other is control dependence. Control dependence is basically that we have a conditional branch and we should not perform, for instance, the then or else case before we know which one we should do. That's informal and quite obvious explanation. If you have taken optimizing compilers or plan to take it, then there will be a much more detailed and useful definition of what control dependence means. But actually, for this course, we can ignore control dependence, because in the C standard, it's only data dependencies that are considered. And related to avoiding data races. And as a matter of fact, we will see that this can lead to unexpected results. Okay, but let's look at dependencies now, and data dependencies and dependency ordered. So in this case, we have data dependence from this write to this read, and when we say that there is a dependence from something to something, it always means, and not only in this context, it means that the first, A is the one that should be executed before B. So if there is a dependence from A to B, it means A should be executed before B. Okay, and obviously both compilers and hardware must preserve this order. And we also can say that A is sequenced before B, since there is a semicolon between these two statements. Not only a semicolon, but more importantly, a sequence point. So now the definition of dependency in standard C. So we say that A carries a dependence to B if A is an operand in B, or that A writes to essentially some variable that B reads, and that A is sequenced before B, or for transitivity that some evaluation X and A carries a dependence to X and X carries a dependence to B. So by transitivity A is then B is dependent on A, or alternatively A carries a dependence to B. And recall that the dependencies are always within one thread or intra-thread. So I mentioned before what a release sequence is, but it was in the context of a release, a modification to an atomic variable, and there was a release, and then I said that it is allowed that there are a sequence of read, modify, write accesses by other threads to the same atomic variable. Okay, so formally a release sequence is the longest such sequence before the thread, the operation B, is accessing this atomic variable. What this means is that the first thread that does the A operation, it performs a release on an atomic variable, either with a store with memory order release, or relaxed and a release operation as a fence. And then the important thing is that the other operations in this sequence, they are read, modify, write, meaning it would not be sufficient if they were writes, because they must be ordered with respect to the first release. So they must read the value that was written and then do something with it and compute some possibly new value and store that, and then the next reads and does the same, and eventually this B operation is executed by some thread. Okay, so an operation or evaluation of an expression A is in one thread is dependency ordered before another evaluation B in another thread if A performs a release operation on some atomic object M and B performs a consume operation on this M and reads the value written either by this A or in the release sequence of A, meaning whatever was read and modified by this sequence. Alternatively, and again for transitivity, if some evaluation X, for some evaluation X, A is dependency ordered before X and X carries a dependence to B, then A is dependency ordered before B. Okay, so now we can see how to avoid a data race in C and C++. What is important to achieve is inter-thread happens before, meaning we can be guaranteed that there is no data race. Okay, and there are two ways basically, plus transitivity. So if A synchronizes with B, then A interthread happens before B. And recall, A synchronizes with B means using either mutex unlock and lock or release acquire on an atomic variable, including a release sequence. I mean, read, modify, write by other threads in between. Or that A is dependency ordered before B using release and consume. And as well for transitivity, that A synchronizes with X and X is sequenced before B. Then A happens before, interthread happens before B, or that A is sequenced before X and X synchronizes with B, or A interthread happens before X and X interthread happens before B. Okay, so now we come to the important thing in the C standard, namely an evaluation A happens before an evaluation B if for one thread A is sequenced before B, or between threads A is interthread happens before B. So if these two are satisfied, then we have no data race. And now we come to the tough situation if we don't satisfy this. The execution of a program contains a data race if it contains two conflicting actions in different threads, at least one of which is not atomic, and neither happens before the other. Any such data race results in undefined behavior, so the computer can explode. Well, if we are unlucky. If we are lucky, it crashes and does so with our computer and not when somebody else is using our program.